and hi, I'm Khadijah, and I'll be discussing on question 1. Explain the meaning of differentiation and what are the techniques of differentiation. First of all, what is differentiation? Differentiation is a fundamental concept in calculus that involves finding a derivative of a function. It measures how a dependent variable y changes in response to a change in an independent variable x. To understand differentiation, we first need to know about two types of line. The second line connects 2 points on a curve and gives the average rate of change. Its slope is calculated as m equals y2 minus y1 over x2 minus x1. The tangent line touches the curve exactly at one point, giving the instantaneous rate of change, the rate of change at that exact moment. As the gap between the 2 points gets smaller and smaller, as h approaches 1, the second line becomes the tangent line. The slope of the tangent line is the derivative. This brings us to the first principal formula. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Are the techniques of differentiation. First is constant rule. The derivative of any constant is always 0, written as d over dx of c equals 0. Next is power rule. Brings the exponent down and reduce the power by 1. So d over dx of x to the n equals n times x to the power of n minus 1. Next is product rule, used when two functions are multiplied together. The formula is d over dx of u times v equals u times dv over dx plus v times du over dx. Next is quotient rule, used when one function is divided by another. The formula is d over dx of u over v equals v times du over dx minus u times dv over dx all over v squared. This chain rule, used for composite function. A function is another function. The formula is dy over dx equals dy over du times du over dx. Next is sum and difference rule. Simply differentiate each term separately. D over dx of u plus or minus v equals u prime plus or minus v prime. And the last one is implicit differentiation, used when y cannot be easily isolated. Differentiate both sides with respect to x, apply the chain rule to any y terms, and then solve for dy over dx. And the last one is for special function rules. Trigonometric rule for a periodic function like sine, cosine, and tangent. D over dx of sine x equals cosine x. D over dx of cosine x equals negative sine x. D over dx of tan x equals sec squared x. And the last one is exponential and logarithmic rules. D over dx of e to the x equals e to the x. And d over dx of ln x equals 1 over x. And that's all from me.
Hi and Assalamualaikum. I'm now AQILAH binti ABDULLAH, and today I'm going to present the solution for question 2c. The question asks us to find dy over dx for the function y equals to 3x e the power of negative 2x plus 5 and simplify the answer. The first step is we need to identify the rules. Looking at the equations, we have 3x e the power of negative 2x plus 5. So the first term is 3x e the power of negative 2x, while for the second term is 5. The first term is we need to use product rules because the first term is a combination between two functions, which is 3x and e the power of negative 2x. So the formula of product rules is uv prime plus vu prime. Meanwhile, for the second term is 5. 5 is a constant number, so we need to use constant rules, which is whatever numbers, when we differentiate them, it's going to be 0. Step 2 is to apply the product rules. Let's define our u and v for the first terms. U is 3x. When we differentiate it, it's going to be 3. 1 multiplied with 3x x1 minus 1 using power rules, and x the power of n minus 1. So the result will be 3x the power of 0. And then x the power of 0 is equals to 1. And the result will be 3. So for the v, e the power of negative 2x. So here we're using exponential rules. E the power of x equals to e the power of x. It's just stay the same. So, and then we need to differentiate the inner terms. So the result will be negative 2 e the power of negative 2x. Step 3 is we need to combine the terms. Now substitute this into the product rules formula. So we get the uv prime plus vu primes. So 3x multiplied with negative 2 e the power of negative 2x, and then plus e the power of negative 2x multiplied with 3. So the result would be 3e the power of negative 2x minus x e the power of negative 2x. Step 4 is to differentiate the constants. 5 equals to 0. Step 5 is to combine and simplify. To get the final neat answer, we arrange the terms to put the positive number at the front while the negative number at the back. So I just write it down. dy over dx equals to 3e the power of negative 2x minus 6x e the power of negative 2x plus 0. And then we do realize we have to factor out the common factors, which is 3e the power of negative 2x. Inside the bracket, 3e the power of negative 2x divide by itself, leave 1s, and negative x e the power of negative 2x divide by 3x e the power of negative 2x, leave negative 2x. So this gives us the final simplified answer. Thank you. That's all from me.
My name is ADRIANAHANI and I got question 3 to solve. For the question that I got is y cubed equals to cos square 2x plus tan in a bracket xy. Okay, for this question we have to use a differentiation to get a solution. Okay, we have to differentiate both sides first. After that, we have to combine it and expand it to find our solution. First one, we have to differentiate left side. The left side we got is y cubed, so we have to write it in d over dx in a bracket y cubed. And then after we simplify it, we got 3y square dy over dx. Okay, so for the right side, we have two types. The first one is cos square 2x, and the second one is tan in a bracket xy. Okay, so for the first one, I am going to take cos square 2x to simplify it. And we have to use a chain rule for this. So we have to write it in d over dx in a bracket cos square in a bracket 2x, and we have inner and outer. We have to simplify the inner and outer one, and we got 2 cos 2x in a bracket negative sign 2x, and we got 2. For negative sign, we know that is a derivative for cos. And after we simplify it, we got negative 4 sine 2x cos 2x. For the second one, tan xy. Okay, for tan xy, we have to write it in d over dx in a bracket tan in a bracket xy. And then after we simplify it, we got second square xy dy over dx and in a bracket xy. We know we got this because we have the two sides, which is inner and outer. And after that, we have to simplify the d over dx xy, and we got x dy over dx plus y. Okay, so for tan xy, we have to write it in a full one. So we got second square in a bracket xy in a bigger bracket x dy over dx plus y. Okay, and then after that, we have to combine simplify the chain rule that we did. Okay, so we have to combine it. We got 3y square dy over dx equals to negative 4 sine 2x cos 2x plus second square xy x dy over dx plus y. And we have to expand it. 3y square dy over dx equals to negative 4 sine 2x cos 2x plus x second 2 xy dy over dx and plus y second square xy. And then we have to collect the dy over dx in the same side. And we got 3y square dy over dx negative x second square xy dy over dx equals to negative 4 sine 2x cos 2x plus y second 2xy. Okay, and then we have to factorize the solution. We got we have to write it in a bracket 3y square negative x second square xy, and we have to close the bracket. Dy over dx equals to negative 4 sine 2x cos 2x plus y second square xy. And we have to solve the dy over dx. So we write it in negative 4 sine 2x cos 2x plus y second square xy over 3y square negative x second square xy. And that is our solution.
For this question, I use linear explanation to estimate the value of cube root of 63.99 minus 2 over square root of 63.99. First, I let x equal 63.99. So the function becomes fx equal x power of 1 over 3 minus 2x power of minus 1 over 2. Then differentiated the function to get f prime of x. Next, I choose x0 equals 64 because it is very close to 63.99 and easier to calculate. After that, I find the change in x. For example, x equals 63.99 minus 64. then x equal minus 0.01. Then I substitute everything into the linear exponential. Formula is fx exponentially equal to fx0 plus f prime of x0 multiply x. In the video, have the formula. Finally, I got the exponent value of 3.7498. I take 4 decimal place because the equation asks for 4 decimal place.